Hello, today we're going to talk about Objective-C, specifically classes and objects. We'll look at declaring and defining a class, what a class is, what an object is, instance variables, or IVARs as they're sometimes called, and properties and methods on a class. So let's get started. First of all, what is a class? A class is a data structure that has both data, just like a C struct would have data, and methods or functions, member functions, to operate on its data. So we can think of a C struct as kind of like a class without methods, and we can think of a class as sort of like a C struct with methods. Classes are everywhere in Objective-C and everywhere in iOS. It's an object-oriented model. So classes are used to control views, and view controller is always a class. They can model the data in an MVC approach, and for many other purposes. They're ubiquitous in Objective-C and iOS. So a class is really a template for an object. We might think of a class animal. An animal class could represent any animal at all. Animals have attributes. They have a certain number of legs, they have wings or they don't have wings, they have a certain kind of fur or they don't have fur at all, or feathers or fins or what have you. And those attributes are the nouns that describe an animal. It also has methods. It has verbs. It has actions. Animals eat, they move, and they do other things. And so those methods are the verbs or the actions appropriate to the class that we're modeling. One of the things that is very important about the whole idea of classes and objects is that classes nearly always inherit properties and methods from some other class. We call the class that is inherited from, we call that the superclass. And we call the class that is inherited from the superclass, we call that the subclass. There is a parent-child relationship. The ultimate parent class in iOS is called NSObject. NS, for historical reasons, NS stands for Next Step, which is a company that Apple used when it was designing the Cocoa product. On the other hand, an object is a specific case or an instance of a class. So again, thinking about our base class animal here, a bird object would be a specific kind of an animal, or a specific instance of class animal. We use that word instance and the word instantiation. We say that we instantiate a class when we make an object of that class. So an object is an instance of a class. A class declares instance variables that that object can use. It has instance methods that the object can make use of. Declaring an object, again, is called instantiation. We keep referring back to this word instantiation when we're talking about a specific object of a certain class. So how do we do that? Well, instantiating an object is a two-step process. First of all, we have to make space for it. The space that we make for it is always on the heap. We always declare a pointer to a class. Well, actually, it's a pointer to an area of memory on the heap that will hold our object. So we allocate memory for that on the heap, and we do that with an alloc method. And we initialize the object using an init method. And the syntax here, we can see this is one syntax that is very often used. We see the name of the class, and then the name of the object that we give it, this particular instance of this class. And we notice that this is a pointer because we are allocating the space on the heap. And then we again have the name of the class, and then we call the alloc method on that class. And then we initialize it, calling the init method on that. The square bracket notation with the name of a class, or actually in this case, this class name and then Alec, or the name of an object, which is actually what this call returns, is an object at a specific place in memory on the heap. That square bracket notation is the way that we call a method in Objective-C. So let's take a look at that. What I have here is a very simple demonstration. This is our main file, and here we see that we have a class called line. We're instantiating an object called myLine from that class by allocating memory, the size of line, and initializing that memory space and returning that into the myLine object. Our declaration of this class is here. Declaration of a class is in a header file. This one is called line.h, and here is our class declaration. Interface and end holds that class declaration. We can see that this line object inherits from NSObject. NSObject is, again, the ultimate iOS parent class for all objects. And in the implementation file, the M file, we do things to define that class. So this is actually the definitions of our methods for the class, and we'll take a look at this synthesize line and what it does, and also these property lines and what they do very shortly. In fact, we're going to look at that right now. The instance variables are, again, that word instance, it refers to an object. We declare instance variables in a class. We can also predefine instance variables in a class, but they're not in scope, they're not usable until we instantiate an object from that class. So in iOS 5, instance variables, or IVARs as we call them, are declared as properties with that @property syntax in the header file, and they are synthesized with that @synthesize syntax in the implementation file. We'll look at that again here in a second. But the important thing to remember about that is it gives us access to our instance variables through nice, safe getters and setters. Now, getters are functions, member functions, methods, that are used to access the value of an instance variable. And setters are used to mutate or change the value of an instance variable. The reason we do this through functions and not by directly getting and setting the instance variable directly has to do with an object-oriented concept called encapsulation. And we'll talk extensively about that and refer back to that several times during the course. In fact, one of the things I want you to do at the end of this lesson is to go back and read about a couple of object-oriented concepts, and one of those very important concepts is encapsulation. So we want to use getters and setters rather than directly manipulating the instance variables themselves. We get something out of this approach, the property and synthesize, called dot notation. Now, dot notation allows us to use the class name or another keyword called self, perhaps, to access those IVARs rather than calling a method such as set point or set this or get this. And we'll see that here right now. In our main, after we've instantiated this object, myLine, we're using here myLine dot startx equals 50. Now, myLine dot startx is the setter method for the startx property in the myLine object. Let's look at that. We have a property called startx, start y, end x, end y. And we synthesize all four of those right here. Now we could synthesize these four on separate lines. It really doesn't matter. I like to group them according to function, kind of a self-documentation piece, but if you prefer, you can put them on separate lines. And then here in our slope function, we're returning the slope of the line. This is just calculated from these values. And we use a keyword called self. Self is this instance. In this case, we are referring to the line class, but it really is the instance object that this line class refers to. So in this case, it's myline. So what that does is it sets myline's start x to 50, and it sets start y to 50. All of these properties are on myline, not in the line class. They are instance variables. We don't see those methods. We don't see set start x and set start y and get and all of that. We don't see them because synthesize and property does that magic for us. It creates those methods. And then the dot notation we get from property and synthesize, and it's very nice. Methods, on the other hand, are the verbs. Properties the nouns, methods are the verbs that a class uses and an object uses to modify or to operate on the data within the class, on the object. Methods, again, like properties, are declared in the header file and they're defined in the implementation file. Methods, though, can take one of two forms. They can either be instance methods that operate on an object. They can only be called from an instance of the class. Or they can be class methods, which operate directly on the class itself. Class methods cannot use IVARs because IVARs don't have scope until the instance is made, the object is instantiated. But the instance methods, of course, can. Instance methods are prefixed by a dash, and class methods are prefixed by a plus. So let's look at an example of each of those. In our line class, again, we declare two instance methods in the interface file, the H file, draw and slope, and we declare one class method, length from x1 and y1 to x2 and y2. Now we're going to talk about this kind of syntax here, but for right now, method names, the parameters of a method are interleaved with the name of the method in Objective-C. The name of this function, the name of this method, is length from x1 colon and y1 colon to x2 colon and y2 colon. Some people say the colon, some don't. Either way is fine. But here's this class method again, and again the same header, just like a function, except, again, the parameters are interleaved with function name, the method name. This class method takes the x1 and y1 coordinates and the x2 and y2 coordinates and returns the length between those. Now, it has to take these in, and it can't operate directly on these because, again, it's a class method. Class methods cannot access member data, can't access instance variables. I have that commented out up here, but let's go back to our presentation briefly, talk about the next thing. Here we see that again. The method name is interleaved with its parameters. Here's an example, a different example. This presupposes that we have an object called myPoint, and this moves a point by an x amount and a y amount. Again, move by x colon and y colon, and then the parameters are interleaved within the function name itself. It returns a float. And here we can also see it's an instance method rather than a class method. And again, we return a float, we're calling that move, and then myPoint, and again, in our square brackets, this method notation, move by x of 20 and y of 15 is how we would call this. Just like passing parameters to a C function. The difference is the interleaving of the parameter with the function name. So again, looking at this, if we run this now, and again I have that class function, or this class member function commented out, but if we run it now, we will see that we have used those setter functions to set coordinates, and then we printed those coordinates out. These are the getters: myline.startx, .startY, .endx, .endy. These are the accessors. These are the mutators. The setters up here and the getters down here. And then we print out the slope using that slope function. And again, that slope function has no parameters. We just use square bracket myline space slope square bracket. And we see that indeed we get the correct values and we get the correct slope. Now, if we uncomment this section, here we have a floating point variable called line length. And note, we're calling directly on the line class. We're not calling on myline. In fact, we haven't even instantiated myline yet. And we're getting a length using that class method from 2030 to 1529. And then we're just printing that out using variable interpolation in the printf function. If we run this, we will see that we get the length of the line is 5.09902. And again, that is calculated just by returning the square root of the sum of the squares of the two sides. We're getting the hypotenuse of a right triangle here. These, I'll mention just briefly, these math functions we actually get from standard library, the C standard library, and I'm including that in the header file of my class. Note also that our class implementation imports the class interface file, the header file, and our main, which uses this class and actually instantiates the class, imports line.h. Now, import, as opposed to include, the C preprocessor directive include, import takes care of some of the circular referencing issues that include doesn't. So we want to use import when we're working with Objective-C. We don't want to have linker loops because we import a file that imports the same file back and another file and so on and so forth. So import takes care of a lot of those issues for us. So that's really it for today, for this presentation. I do want you to take a look at the Apple documentation on properties and synthesize so that you see what those are actually doing. Also, in properties, take a look at that non-atomic versus atomic. We really won't get to multiple threads of execution for quite a while, but it's good to have some of that basic knowledge and why we use non-atomic, because there is quite a bit of overhead in creating thread-safe setters. We also want to look at, or I would ask you to look at, the concepts of inheritance and encapsulation as they apply to object-oriented concepts, and think about, in this particular example that we've seen today, how those concepts apply. Thank you very much, and I hope you can use some of these ideas in your own